here that I would like to go over as an initial session, and then what I'm really looking for is some feedback and to understand maybe what you guys out there are looking for. And if you want to share that with me, send me an email. Give me some information on what you would like to see, and I'll incorporate that into some sessions going forward. A couple other ideas I have are a security session, which I think will be quite popular. And then we're also going to incorporate maybe along the way every other session we might do a new release, or a lot of times features get added that sometimes some folks don't realize are there. So I'd like to go over what has happened over the past couple months, what's new inside the network, what's new inside of Wi-Fi and what's new inside of Aerohive. So kind of add those together and kind of get a briefing on that. So, on my screen here, you see a list of things. This is just a general outline of some of the things I'm going to try to cover here. And like I said, this is just kind of a first go around. This is really what I came up with. I'm really looking forward to the feedback. And so if you have any questions as I'm going through this, feel free to jump in and ask any questions. I'd like this to be kind of more interactive. But without further ado, I'll start going ahead here. And so really, I'm just starting this off with some Aerohive CLI commands. So if you're NG or you have an access point and you just want to see some of the data and the raw details, and there's some of the more popular, more informational CLI commands here, and some of the output, some sample output. I'm showing just Wi-Fi 0. So on our access points, Wi-Fi 0, Wi-Fi 1, give you information on the beacon interval, how many chains there are. This is going to give you a good indication of the transmit power set on the device. Another one here is ACSP channel information details. So ACSP is a underlying protocol that's run between all the access points, and it shares information about the environment and the spectrum. And we'll get into a lot of that in the next couple slides, but this will give you the information from the AP's point of view, and we can grab some of that data here. And ACSP stands for Automatic Channel Selection Protocol. So it's continuously communicating on the wire and in the air about all the details and data it sees about the environment, whether it's a non-Aerohive AP or an Aerohive AP. So it's giving you all the ins and outs of the whole environment. So Show ACSP Neighbor is going to actually give you information about every AP that it sees, the RSSI strength, CRCs, channel width, all the good information to know how much stuff is in your environment. How many interfering sources there may be. So all this right here adds up to what we call the noise floor. So all this extra data and all this extra information that you see on the screen is stuff that my single AP here can see. So that's a lot of data that, a lot of underlying noise that we have to talk over. So, and to get a good information of that noise, we can run a command called Show ASP Neighbor. Show ASP Neighbor info detail kind of digs down even a little bit more into what we're doing on each channel and what we have found on each channel. So we can go and see neighboring access points. We can go and see aggregate interference, how many interfering devices do we see on the same channel, and so on. And then lastly, of the commands, interface Wi-Fi count is a good indication of how much multicast is on your that you see in your environment. How many CRC errors? CRC errors are kind of correlate with retransmits. They're going to correlate with adjacent channel interference, co-channel interference. Multicast will tax the CPU on the AP itself, right? And we'll talk about some of the things that we do to clean up the environment and just make it a cleaner RF environment in general to try to avoid some of these things. Some of the tools that I personally use, I do walk around with a MacBook Pro. So from a Mac version, for a long time, Mac didn't have a really good application to do spectrum analysis. And so everybody used Windows laptops, Windows 7, Windows 10, things like that. And so the one that I would say would correlate to this one on the Windows side would be something like Channelizer or Insider, something like that, with a MetaGeek type antenna, so you can actually view spectrum. It's written by Andrew Granados, and he has a promotion out now, which allows you to, if you're in education, you can get this program for about 50% off. It's about $100, so it's much cheaper than some of the other ones out there, like Air Magnet, and some of the other well-known ones, which can be quite expensive. But this is probably not going to be the same and in depth as an Air Magnet, but it's going to give you a pretty good indication of the channels out there, the channel utilization. It'll even allow you to put a Wi-Fi DBX and a dongle in here and integrate the spectrum analysis, as you can see in the middle of the screenshot there. So one of the things that I actually like a lot is the off to the right, you'll see the beacon overhead. So this is a good indication of how many devices in that area are beaconing on that channel, and how many APs can you see, which is, you know, part of the conversation when you talk about overhead management. And so it gives you a good indication of all the overlapping APs out there. Some of the things that you can see while in this tool that are going to help you along with troubleshooting is it'll give you information like about hidden networks. You know, a lot of folks think that hiding the SSID is, you know, a form of security, when in reality, there's a lot of drivers out there that don't necessarily like hidden SSIDs. And so if you run across some issues with client devices and you're hiding a lot of your SSIDs, it could be related to that. Also show you stuff here about legacy equipment, open or weak signals, things like that. Like I said, one of the things that I like on this particular tool is the channel utilization. So this will give me an indication of how much channel I actually have left, how much data we have left in the spectrum. So as you get up to around 60–70% of the spectrum used, at that point, there is no more data to be had, at least as far as passing data, because the rest of the spectrum is being used by overhead management. So this is a good indication here. If somebody, you know, says they're having an issue, you can go back and look at a time frame here and say, oh yeah, well that makes sense because you know, you were saturated at this particular time. You were at about 70% channel utilization. Therefore, if you were experiencing slowness or, you know, something to that effect, we can correlate that with how much of the channel was utilized at that time. And then lastly, this is just an overview of, I actually have a Wi-Fi DBX card plugged in. So when you have the Pro version, it allows you to plug a Wi-Fi DBX dongle in and get some spectrum analyzing. So you can get the waterfall effect here. So as you see more and more data, that waterfall turns more red. All the black space there is open and free space to be used at that time. So the darker this gets, the more saturated the environment is. Also by Adrian as well is another tool called AirTools. This is just something I use along the way as well. And I use this to easily capture data in the air. So if I see anything going on, once I've checked the spectrum looks clean, but there's still things going on. Maybe it's some authentication issues, maybe our device is having problems connecting. I can actually go in and run a packet capture in the air and pull down those packet captures, and then I can push those out automatically to a Wireshark or even a couple online tools as well. So something similar to this would be AirPCAP for a Windows device. So AirPCAP is very similar to this on the Windows side. So getting into a little bit more of just the Wi-Fi itself. So CCI, CCA. So CCI is co-channel interference. Along with that, you might hear terms like ACI, adjacent channel interference, and then CCA is just what happens on the AP in the management. It's a clear channel assessment. So it's basically the AP and the way that it senses for RF energy. And then once it senses for that RF energy, if it sees that RF energy, it'll run a back off algorithm and then try again later. So, you know, as you can see here, there's four overlapping cells all in channel 1. So at this point, you're going to have a lot of co-channel interference, a lot of contention in the air. And the goal here is to either shrink your cells, control the power a little bit more, or distribute your channels a little more accordingly. And we'll talk about 2.4 versus 5 gigahertz and the challenges that you will run into when you start talking about those two spectrums. All right, so so along with talking about clear channel assessment, CCI, co-channel interference, things like that. It really comes down to channel reuse. And so in the 2.4 spectrum, you have 1, 6, and 11 in the United States. You have in other countries, you can actually use channel 14 as well. So there's 4 in the 2.4 spectrum. But all that really means is if I want to reduce the amount of co-channel interference in my environment and I'm using 2.4, I use 1, 6, and 11. And when I get to my 4th AP, I have to reuse one of those channels. And if I don't have these APs spread out far enough from each other, I have to try to control the transmit power as best as I can. And with 2.4 spectrum, with the wavelength, since it's much larger, it's a little bit more difficult to control the 2.4. So by the time you get to your 4th AP, you're probably introducing some interference or some contention at that point. That's reasons why a lot of the market is moving more and more towards the 5 gigahertz spectrum. And again, you know, obviously patterns here, in this particular screen, you're seeing that you're using 2 channel 1s, but in theory, you're trying to minimize the amount of transmit so you don't have as little contention as possible. And so does RF really just stop? Yeah. So the transmit, and when we talk about RSSI, we're always talking about the RSSI that is typically within the range of an MCS value where you have the highest data rates for your devices. But after your device gets its highest data rate, since it's since the RSSI is really strong, the signal noise is good, that RF doesn't stop there. That RF keeps going through the environment. It actually can penetrate walls, and so you can still see these devices at neg 80, neg 85, neg 90, several walls away, and those also have to the APs that can see those still have to acknowledge that AP is there, and it still has to actually contend for that airspace. So RF doesn't stop after it hits the clients; it continues, and so it's that's why 2.4 is very difficult and challenging to control, primarily because of the wavelength. So in this scenario, when you're deploying, I deploy typically always for 5 gigahertz, and I know if 5 gigahertz is going to cover my environment, I know for sure that 2.4 is going to cover. Yeah, so also one thing to consider as well is it's not only the APs that cause the source of contention in the air. It's a lot of times it's the actual stations themselves. So if you have a room with about 30, 40, or 50 devices in that room, the noise from the devices themselves, the noise floor is going to actually get a little bit higher, which is going to bring down your signal to noise ratio, because all these devices are sending probe requests, and they're contending for airspace and transmit opportunities. So you have 30 of these devices with 1 AP in that room. These devices become the contention for that airtime. So it's not only just the APs in the environment, you have to consider all of the stations as well when it comes to that contention in the air. So what do we do to kind of alleviate contention and try to help with the overhead management is to minimize the amount of SSIDs we have in the air. So there might be times where you've walked into an environment and saw 6, 7, 8 different SSIDs, and sometimes that's driven by management who isn't non-technical management, who says, hey, we need a new SSID, we have this group, and they say, hey, we need a new SSID for another group. And before you know it, you have all these SSIDs, and all these SSIDs got to contend for that airtime. So every network gets broadcasted through a beacon from the AP 10 times per second. So if I have 7 SSIDs, I'm broadcasting every second 10 beacons for every network I know. And as you get more and more, obviously with more and more SSIDs, you're going to have a lot of overhead management, and your consumption of airtime is going to go pretty high. Kind of going back in this particular screen you see here, if we remember back on the screen where I was showing the tools with the Wi-Fi Explorer, there was the beacon indicator in the top right-hand corner. So that's going to show you how much of your airspace is just APs beaconing about networks before you ever pass any data for the client. And so what we can do for scenarios like this is we can actually start to consolidate a lot of these SSIDs. And within the Aerohive network and inside of the Hive Manager, we can do that through a couple different ways. We can have a private pre-shared key, and inside this private pre-shared key, we can create things called user profiles. And so inside these user profiles, so instead of having an SSID for marketing, an SSID for sales, an SSID for IT, we can actually create a single SSID and give each group their own private pre-shared key. And then inside that SSID, we can break it up into user groups, and we can actually create groups very similar to using like 802.1x with Radius. We can actually do that through a private pre-shared key. And so, yeah, adding different groups for the same SSID. So basically, so you can actually give out different VLANs for different groups. You can apply different firewall policies. So there's a lot of different things you can do, very similar to something that you would do on a .1x scenario. Or if you look at all these different SSIDs, they all have probably different policies. We can actually consolidate all those policies into that single SSID as well. And this is just an example of some of the, what you might see with using user profiles, where you have like an employee group marketing voice. So you have a bunch of different policies here, and we can actually apply a policy and say, hey, anybody who has a client OS of a BlackBerry, we can put them in the VLAN 33, and that's based on the fingerprint of when they come into the network. And so we have the ability with the PPSK and using user profiles to really kind of segment the network, but also gives us the ability to consolidate those SSIDs. Another way when talking about SSIDs is to start removing specific data rates. And so the idea here is to not allow maybe B clients on the network. And pretty soon with AX coming up, we probably will start maybe pushing off the G clients and maybe the A clients and other clients that are going to kind of require the radio to be backwards compatible to the older legacy clients, so that the newer clients, so the older clients can connect to the newer type devices that are out there that are pushing the newer standards. And so, the aggregate throughput, obviously, within the environment, you take your data rate. And so what that basically means, so if you take your data rate, let's say with .11n, you have 300 megabits per second data rate. That data rate is not including, so that's your data rate, but that doesn't give you the whole picture. So TCP throughput of that data rate is typically 40 to 50% of that value. So if you have a data rate of 300 megabit per second, your throughput in a clean environment is going to be 40 to 50%. And so with .11n, .11ac, with error correction that was added to the standard, we can see, and especially in a cleaner environment using 5 gigahertz, we can get that number up to about 60 to 70% of the actual data rate. And so what that might mean is disabling some of these basic data rates for the clients for their beaconing. So this is something that we can do to remove some of the older clients so that they don't, raise the amount of airtime consumption and things like that as well. So you might disable 6, 9, 12, and 18, which is going to basically remove the capability for any .11b client, and any lower data rates on the G clients as well. And this here is in the 5 gigahertz where we would do the same thing. And oops, sorry about that. And we would do the same thing for the G clients as well. So band steering. So inside the Hive Manager for band steering, so typically band steering, you have a 5 gig and a 2.4 radio is your standard on most APs. And so what happens is the AP wants to basically look at that probe request coming from the client. That client will typically send information about what the different supported rates and the different supported bands that it can support. And based on that, what we'll do for band steering is we will encourage that device to go to 5 gigahertz. And the way that's typically done is by not necessarily answering their probe request when they send it from the 2.4 radio. We'll wait until they send us a probe request from the 5 gig radio. And so we steer them over to the 5 gigahertz. So that's pretty good. That's pretty good. But you know, if you have a statically 2.4 and a static 5 gigahertz, you could be in an environment where majority of all your clients are going to be on the 5 gig radio. There might be a couple, 2 or 3 clients on the 2.4 radio. So we'll talk about this later, but there's a scenario where we can actually use all this information, engage the environment, and use software-defined radios to turn that 2.4 radio to have a dual 5 gigahertz AP. So therefore, when I do have clients come in, I can do some other things as far as band steering. I can do things like I could allow .11ax only clients to connect to this one 5 gigahertz radio, and then my other 5 gigahertz radio, I may handle maybe some of the legacy clients. And therefore, you have all your AX clients who are the really fast clients kind of all grouped together, and maybe some of your legacy clients can contend for their radio. Yeah, so this is just another screen, just kind of, so these are screens here kind of showing the radio profile and where we would set that in the Hive Manager. All right, so here's a band steering animation. So like I said before, there's a probe request that comes from each client, and 2.4 only clients obviously hit the 2.4 radio, but the 2.4 and 5 clients, when they're out of range of 5 gigahertz, they'll obviously go over the 2.4, but when they're in range, we'll ignore their 2.4 and we'll encourage them to go to the 5 gigahertz. That's all good. There are scenarios where clients send their 2.4 probe request. And so at that point, sometimes they'll stop trying to connect altogether. So you may hear scenarios when you're troubleshooting, yeah, I see the network, but my device won't connect. That's because sometimes these client drivers don't like when we ignore